Hello there, ladies and gentlemen. Welcome to another note session with Mrs. Winsley. The first thing I want you to do today is put your name on the top of the paper. This still has not been happening for everybody, and then I don't know who to give credit to when you turn stuff in. Your name always needs to be on the top of your paper. Now, our I can statement for today is I can use two-dimensional nets to represent three-dimensional solids. I can find surface areas of rectangular and triangular prisms, and I can solve real-life problems. I realize that I did not put that on your notes, but that is okay. Our essential question is, how can you find the surface area of a prism? So, the first thing we're going to look at is the general definition of the surface area of a prism. The surface area, represented as a capital S, please note that that is a capital S. That's going to be important later on. Of any prism is the sum of the areas of the bases and the lateral faces. L-A-T-E-R-A-L, lateral. Can be represented very simply as S, capital S, equals areas of the bases plus areas of the lateral faces. Surface area of a rectangular prism. The word form is the surface area, represented once again as a capital S, of a rectangular prism, is the sum of the area of the bases and the lateral faces. Alright, so if we look right here, this is a rectangular prism. This right here is known as the net of the rectangular prism. The net is when it's all folded out. A lot of times I will give you the net of something if we're going to cut it out and fold it up. When we made the cube for our vocab earlier this year, I gave you the net, you filled it out, and then you made a cube. So the area, the algebraic form of the surface area, is stated right here. I just want you to rewrite it to practice it. It helps get it in your brain better. So we're going to have capital S equals 2 times length times width plus 2 times length times height plus 2 times width times height. All I did was rewrite the equation. It can also be stated as S equals capital S bases plus sides plus the front and back. So if we look back up here, it would be our two bases plus the two sides, which here are squares, plus the front and the back, which here are rectangles. The lateral surface area of a prism is the sum of the areas of the lateral faces. the sum of the areas of the lateral faces. So we don't include the bases or the top and bottom here. We just do the sides and the front and the back. Okay, if you need more time, pause the video. Otherwise, flip your paper over and continue. We're going to look at an example here. For our first example, I want you to draw the net. So we're going to draw what it looks like when it is all unfolded or all spread out in a two-dimensional form. When we do this for this shape, what you need to do, at least what I do, is I draw the lateral faces first, and then I draw the bases. So I'm going to do this first side, that would be over here, and that is a rectangle. And just do the best you can. Clearly, I do not expect it to be perfect because mine will also not be perfect. There is a thinner rectangle in the middle. So we're going to do another one that's the same height, but it's skinnier. I'm going to do another one of these. Now, if we did this perfectly, we would get out a ruler and measure it out, but I just want you guys to get the understanding of it. So these two are going to be about the same. And then we have another long, skinny one. Now we would want to label these. So this side right here, this is going to be 5 inches. This side is going to be 6 inches. This little length right here is 3 inches. This one is also 5 inches. And then we need to draw our bases. Our bases are the same width here as those long, skinny rectangles. So I'm going to do the same thing here and the same thing here. But they are not quite as long. So these ones are 6, but these ones are only 5. I'm going to draw it a little bit shorter. Now you guys are much better artists than me, but just do your best. This length up here is 3 inches. I realize my numbers are crooked. That is because I'm drawing from the side. All right, now I want you to rewrite the equation that you're going to use. That equation is exactly what we just copied down on the front, which is S equals 2 times length times width plus, which is the bases, plus 2 length times height plus 2 width times height. Now we're just going to plug the numbers in and then solve. So S equals 2 times 3 times 5, because this one right here is 5 inches. So we're going to go 2 times 5 times 3. Now please note that we would not use the distributive property here. Many of you are probably going to try to say that 2 times 3 and 2 times 5 will give me the answer, but that is not correct. It is not the distributive property. We want 2 times 5 times 3 or 2 times 3 times 5. Then we're going to add in 2 times 3 times 6. That's going to be this one and this one. So now we have our bases, 5 times 3 and 5 times 3, and we multiplied it by 2. So we have 2 bases. We did 2, so there's 2 of them. Times 6 times 3, so 6 and 3, it's these long skinny ones. Now we still need to add in the 2 times 5 times 6. Now right here, 2 times 5 is 10. Oops, I changed the order. We have to have length times width. Now, multiplication is commutative, so we still would have gotten the same answer, but for the purpose of the equation, I want you guys to have the right numbers, please. 2 times 3 is 6 times 5 plus 6 times 6 plus 10 times 6. 6 times 5, we're going to have 30. 6 times 6 gives us 36. 10 times 6 gives us 60. If we do 30 plus 36, we're going to have 66 plus 60. And this should give us 126. So we're going to have 126 inches squared. Now try to do this on your own. I realize I didn't quite leave enough room. Actually, yours will have enough room for the net drawing and solving the equation. This is mine before I made your copies. All right. Now we're going to move on to example 2. First thing I would like you to do, once again, is to draw the net. This net is going to look very similar, but it's also a little bit different because we have a different number of faces and we have triangular bases. So the first thing I'm going to do is I'm going to draw the lateral faces. All 3 of them are a little bit different sizes, but they're all rectangles. So I'm going to draw 3 rectangles that are a little bit different. The middle one is going to be my largest one. This one is going to be my smallest one. This one is going to be a medium one. And now my triangles are going to be, they're going to have the same base here and here. They're going to connect to the center one. So I'm going to draw a slant here and connect it here. And it's going to mirror it on this side. Once again, I realize it's not perfect. This is just a sketch of the net so that we can see what we're working with. All right. Now I want you to make sure you label the bases and the faces. And we want to label them with the numbers and what they are. So I'm going to put a B in here. Also, we want to label this right angle. That right angle is up in this corner right here. So it's going to be in this corner right here. This is a base, this is a base. And these 3 are the faces. Alright, I'm also going to label them as face 1, face 2, and face 3, just so that it's easier for the next step that we're going to do. Now we're also going to label these sides. When we label them, we have 3 meters here. We have 4 meters over here. I have 4 meters right here. 6 meters right here. The triangle down here is going to be the same. 3 meters, 4 meters. Let's see, did I miss it? Oh, this one is 3 meters. Now, we know once again that this side is going to be the same. It's 6 meters. This one's going to be 4 meters. And this one's going to be 3 meters. If you want to go through and label them all, that's totally fine. Just make sure that each one is at least labeled once, like I had done it first. So 3, 4, 3, so that the mirrored side you know will be the same. Alright, so now we're going to find the areas of the bases and the faces. Alright, so first the area of a triangle. Our equation is going to be 1/2 times base times height. So we're going to have 1/2 times the base, which is 3, times the height, which is 4. Now instead of multiplying 3 by 1/2 and getting another decimal, I'm going to do 3 times 4, which is 12. And I know that half of 12 is 6. So now the area of the bases is equal to, or equals, 6 times 2, because we have 6 here and 6 here. So it's going to be 12. Meters squared. Now the area of the lateral faces, I'm going to do them from left to right. So I'm going to start with face 1, face 2, and face 3, which is why I labeled them so that it would make more sense down here. Now you're going to use the equation, either area equals length times width, or area equals width times height. Sorry, area equals length times height, or area equals width times height. So the area of face 1 is going to be this 3, oops, too far, this 3 right here times this 6 right here. So 3 times 6. 18. Now face 2 is going to be this base right here, which I missed. It's 5 meters. So it's going to be the 5 meters times the height, which is 6. I'm going to come down here. I'm going to do 5 times 6, which equals 30. And then face 3, we have 4 meters and 6 meters, so we're going to do 4 times 6. 6 times 4 is 24. Oops. So now we're just going to take these 3 numbers, 18, 30, and 24, and add them to our 12. So we're going to do 12 plus 18 plus 30 plus 24 equals our surface area, our big S. Now we know that 12 plus 18 is going to give me 30 plus 30 plus 24. 30 plus 30 is 60 plus 24 is going to give me 84 square meters, or meters squared. When you're ready, go ahead and flip your paper over. Right here, you're going to see a couple of on your own problems. I would like you to pause the video and go ahead and try those on your own now. Alrighty. When all of the edges of a rectangular prism have the same length, represented by little s, a lowercase s, the rectangular prism is a cube. The formula for the surface area of a cube is our capital S, the surface area, equals 6 times our little s squared. So because I want you to, we're going to look at example 3, and because I want you to continue to practice memorizing these equations, I would like you to rewrite it. Capital S equals 6 times little s squared. Now we're going to plug the numbers in and solve. All we have to do with this one is put our number 12 in for our lowercase s, because all of the sides are 12, all the way around. 12, 12, 12, this side's 12, this side's 12, all of them all the way around. We're going to do capital S equals 6 times 12 squared. This is going to be 6 times 12 squared is 12 times 12. 12 times 12 is 144. And then you're going to do that 144 times 6. And you should get 864 meters squared, or square meters. When you're ready, go ahead and turn to the next page. Now we're going to look at an example 4. Example 4 is going to be our real life application. I realize some of you are grossed out by bugs. We're talking about bugs, but we're not doing anything with this. So please do not worry. This is just applying it to real life. The outsides of purple bug traps are coated with glue to catch emerald ash borers. You make your own trap in the shape of a rectangular prism. Like I said, we are not actually doing this, with an open top and bottom. What is the surface area that you need to coat with glue? First, write the equation that you're going to use. I'm going to use the S equals 2 times length times height plus 2 times width times height. We are going to use this equation. We are not going to include the area of the bases, which is the 2 times length times width. We don't need to use that because our top and our bottom are going to be open. We're not going to cover them. So now we're going to plug the numbers into this equation and solve. So we have our capital S equals 2 times our length, which is 12, times our height, which is 20, plus 2 times our width, which is 10, plus our height, which once again, times, not plus, times our height, which is 20. So 2 times 12 times 20 plus 2 times 10 times 20. 2 times 12 is 24 times 20 plus 2 times 10 is 20 times 20. 24 times 20 is 480. And 20 times 20 is 400. Add those two together, and we're going to get 880 inches squared, or square inches. Alright, now I would like you to move on to the next two on your own problems, and that wraps up our notes for today. So go ahead and finish those up and then grab your exit ticket. Alright, I hope the rest of your day goes well.